Okay guys, today we are going to be debunking the myth. Can your solar power your AC for a whole night? So let's assume this client, Mr. Ade, is having a 1.5 horsepower AC, inverter AC please, for 12 hours. He wants to use this AC conveniently for 12 hours. What's the size of the battery that is going to use conveniently to power this AC over the night? We are going to be doing the calculation now. So if you have a 1.5 horsepower in your self-contained and you want to use it over the night, let's see how many battery size you are going to be using. So 1 horsepower AC is equivalent to 1 horsepower is equivalent to 745 watts. So 1.5 horsepower will be 745 multiplied by 1.5. So that's going to be giving you around 1119 watts. So the total power for this AC is 1119 watts. So this is the total power that Mr. Ade is going to be using for the 1.5 horsepower AC. And since he's going to be using it from 6 in the evening, let's assume from 6 in the evening till 6 in the next morning, that's 12 hours. So the total energy consumption, TEC, is 1119 watts multiplied by 12. That's around 13,428 watts hour. So considering our factors that we discussed last week, considering those factors, we are going to be adding them so that we will know the total battery bank that will be suitable for this 1.5 horsepower AC. So let's assume the inverter efficiency, i.e. inverter efficiency, is 90%. So we are going to be dividing this figure by 0.9, 90%. That's 13,428 watt hour divided by 0.9. This is going to give us 14,920 watt hour. Again, another factor that we made mention in some of our previous video is the temperature factor of the battery. So the temperature factor, TF, is also, let's assume it to be 90%. So we are going to divide this one by 0.9 again. 14,920 watt hour divided by 0.9, 16,577.7. So this is 16,577. Another factor that we are going to be considering is the depth of discharge. Let's say the battery is a lithium battery. It has a depth of discharge of about 90%. So the DOD, depth of discharge, is another 90%. So we are going to be dividing it by 0.9, which is 16,577 divided by 0.9, 18,419.8 watt hour. So from this calculation now, you can see that for a 1.5 horsepower AC to run efficiently on battery for 12 hours, you are going to be using 18,419 watt hour battery, approximately 18,500 watt hour battery, which is equivalent to, if you convert it to kilowatts, you divide it by 1,000, 18.5 kilowatt hour battery. So most times when you are sizing your battery, many people, where they got the confusion wrong is that they will only calculate their total energy consumption. They will assume that since this is what they want to be carrying for 12 hours, so this is the amount of energy that they are going to be consuming for that 12 hours. So they are just going to be buying maybe 14 kilowatt battery or 15 kilowatt. At the end of the day, it will not do the function for them because they fail to factor in all this depth of discharge, temperature factor, and inverter efficiency into play. So but when you consider all these factors when sizing your battery, you will be able to size it accurately for it to serve you better. So when next you are sizing your battery, you need to take all these 4 factors that we mentioned into consideration. You understand it better if you watch my previous video. So I suggest, if you have not watched my previous video on some of the terminologies that you need before sizing your battery, your panel, and your inverter, go and watch it so that you understand this video better. See you on the next one.